To video lesson 6.6, Graphing Linear Inequalities. Go ahead and put today's date in the top right-hand corner of your paper, and we'll start off with our I can statement. And it is that I can graph linear inequalities on a coordinate plane. Now, we've graphed linear inequalities before, except on a number line. We're going to look at graphing inequalities on a coordinate plane. So inequalities must be in our slope-intercept form, must be in y equals mx plus b to graph. And just a real quick reminder, remember when you multiply or divide by a negative, the inequality symbol flips. So those rules we had back in chapter 3, they're still relevant. We're still going to use them today with multiplying or dividing by a negative. The inequality symbol will flip. Now, inequalities graph a little bit differently than equations. There's a couple of symbols we need to go over. So, graphing our symbols. The very first thing it does is it changes our line type. We have our first line, which is y is less than or greater than. If you notice, these inequality symbols don't have lines under them, so that means it's a dashed line because that line's not going to be included. It's equivalent to an open circle when we did those on number lines. So if it's less than or greater than, it's a dashed line because it's not included. Our second line type is for when y is less than or equal to or greater than or equal to, because the line is then included in the solution because it is equal to it. Now our next thing is shading. So for shading, we're going to have if y is less than or equal to, we're going to shade below the line. And if y is greater than or equal to, we're going to shade above the line. And over here are just some cases to look to. So for when it's positive, that means the line's going to go up and to the right. Above it is on this side, and below it is underneath it. For negative, so when your slope is negative, above is over here on the right side now, and below is on the bottom left. For a horizontal line, that's a little bit more straightforward. Below and above. Our last one is vertical. And whenever you have a vertical line, remember that's for like when you have x equals a number, because we go through your x-axis at that number. It acts in like a number line where below is everything less than's to the left, so less than is left, and then above is everything to the right, greater than to the right. But just sketch out these different types of slopes. That way whenever you see them, you can always double check yourself and make sure you've shaded the correct region. Now because they're just a little bit different than equations, we're just going to write down a couple of our steps. So step 1 is to write your inequality in slope-intercept form. You want it to look like y equals mx plus b. The only difference is this symbol will be different. It won't be an equal sign today. Now, our second step is to find our slope. And once again, we're graphing, so it's m equals rise over run. To find our y-intercept, which is our variable b. And remember, it's for when we write it as an ordered pair, 0, because it's the y-intercept and then your number. Now, step 3, we begin with b and use our slope for our points. Now, if you look, these first 3 steps haven't changed at all. They are still the same 3 steps we've been using throughout the entire graphing process. Step 4 is where it changes on us. So step 4 says determine the line type and graph. So our line type brings us back up to the top where we have to choose if it's less than or greater than, it's a dashed line, or less than or equal to, or greater or less than or equal to, it's going to be a solid line. So determine our line type. Then step 5, determine the area to shade, and that's our above or below. If it's Less than, it's pointing to the y, it's calling him little, so we shade below our line. If it's eating the y and calling the y greater than, then we're going to shade above. And lastly, we always want to make sure we shade the whole region. Alright, so let's look at some examples now. Example 1 says from the set 1, 6, 3, 0, 2, 2, and 4, 3. Which ordered pairs are a part of the solution set for 3x plus 2y is less than 12? So there's two ways you can do this. You can go above your ordered pairs and write x and y and plug in the values into your equation and make sure it's less than 12. Or what we're going to do today is we're going to graph it and then check the ordered pairs. So once again, if this is my inequality, I need it in slope-intercept form. So I need it to look like y equals mx plus b. So that means I'm going to keep my 2y on the left because it's already there. I'm going to drop down my inequality symbol. It must stay an inequality symbol. Okay? Just drop it down as is. And then I have my mx and it needs to come over, so my 3x is positive. And I bring over here, so it become a negative 3x. And I'm going to drop down my plus 12, which is just my number. So now my last step is to get y alone, is to divide everybody here by 2. So 2's cancel. Y, and then we always check we divided by a positive, so my inequality symbol stays the same, is less than, because it points to the y, calling him little, so y is less than. Negative 3 over 2 doesn't reduce, so negative 3 over 2x plus 12 divided by 2 is 6. So step 1, get it in slope-intercept form, we're good. Step 2 is to find your m and your b. So m is negative 3 over 2, and our b is 0, 6. And now we're going to graph this information we have right here. It's always the final product we always look to when we graph it. Okay? So my B, where I begin, and it tells me to begin at 0, 6. I'm going to go up 6 on my y-axis. So 0, 1, 2, 3, 4, 5, 6. Then my slope is negative, so it tells me to go down 3, so down 1, 2, 3, and right 2. 1, 2. Down 3, 1, 2, 3, right 2. So I've graphed my y-intercept and my slope. Now the next thing I need to determine is what type of line. So we always look to our last inequality symbol and say if y is less than, it's not equal to it, so therefore it's going to be a dashed line because it's not equal to. So come back over here. Oh, let's try our dashed line a little bit better. If you have a pencil, usually if I have a pencil, I make one solid line. I go back there with my eraser and put in the marks to make it a dashed line. Okay, and then my fifth step is to determine where to shade. So once again, we always go back over here to our inequality symbol, and it says if y is less than. So it's pointing to the y. So if y is less than, we shade below. So over here, we're going to shade below it. And below, for a negative slope, is everywhere to the left. And step 6 is to make sure you shade the whole region. So look, my line goes all the way across my graph paper. That means I have to shade this whole region, the whole side of my graph paper. There we go. Now the original question is if these ordered pairs are a solution. Well, this green area now is my solution region. So we just see if these ordered pairs are in my solution region. If they are, then that means that they are a solution. If they're not, that means they're not a solution. So I'm going to real quick go back and box in my information. This is all my information for my graph. Now, let's see about these ordered pairs. So 1, 6. So write 1 up 6. 1, 2, 3, 4, 5, 6. Is that in the green region? No, no, it's not. So that's not a solution. So then we try 3, 0. So start at 0 and then go right 3 and then 0 so we don't go up or down at all. And that is in the green region, so it is a solution. Then 2, 2, so right 2 up 2. That's also green, so it's a solution. Then 4, 3, so right 4 up 3, that one's not, so that one's not a solution. So our solution set for this would be 3, 0 and 2, 2. There we go, and we just found our solution region. So our second example just wants us to graph it, that's all. Just graph negative y minus 2x is less than or equal to negative 4. So first thing, we need to get it in slope-intercept form. Y equals mx plus b, except now it's an inequality symbol. And say my y is already on the left, so I drop him down negative y. I drop down my inequality symbol, less than or equal to. And so if that's a negative 2x and it comes across, it's now going to be a positive 2x. Get rid of that stray point so it doesn't look like it's 0.2. It's whole number 2. And then I drop down my minus 4. Okay. So now we're going to say that's a negative 1 in front of our y. We're going to divide everybody up here by negative 1. So negative 1's cancel, and we get y. Now because I divided by negative 1, my symbol's going to flip and say y is greater than or equal to 2 divided by negative 1 is negative 2x. And then negative 4 divided by negative 1 makes a positive 4. Then we find our slope, which is negative 2. And because it's an integer, we write it over 1. And our b is 0, 4. And now we graph it. So 0, 4 is where I begin. So it's on my y-axis. So go to 0, then up 4. 1, 2, 3, 4. Then my slope tells me to go down 2, right 1, down 2, right 1. Then we come back here and we look at our inequality symbol. And we say, what type of line do I need? Solid or dashed? It's underlined, so I need a solid line. So we come back through here and make a solid line all the way across our graph. And then it says greater than. So greater than means we need a shade above it. So here's all of our information. Come over to our line, and for a negative slope, above it is to the right side. So we want everything above our line, everything up. There we go. And once we have all that whole region shaded, we're good. And this concludes our graphing inequalities. Thank you.